Welcome to Chapter 3, and in Chapter 3 we're dealing with gas laws, but we're going to start with solids, liquids, and gases, and phase changes for those. Now this might be a review for you from past years, but this is a good way to catch up and then get ready to go into just those gas laws. So we'll start first with just our solids. Right, up here at the very top, we have the solids, and you can see from the picture, the solids are stuck together. Right, the forces that are keeping these together don't allow them to move apart. There is some slight vibration, but that force of attraction keeps them together. A solid has a definite volume and shape. You need to know that for not only the mastery check, but for the test too. Now, if we apply a little bit of heat and we turn it into a liquid, this is called the heat of fusion. The heat of fusion is the amount of heat needed to melt a solid. Right? And when we say melt, we're going to have an endothermic reaction. You can see here that it's red in color, right? And we have our endothermic over here, red in color. Takes heat into whatever we're looking at. So then we turn it to a liquid. Now if we take a look at the liquids themselves, we see that they've spread out. It definitely has an indefinite shape, but it has a definite volume. The volume stays exactly the same. The shape shifts, and it kind of takes the flow of whatever container that it's in. Now, we could refreeze that, do an endothermic reaction, the blue reaction. We freeze it, we take the energy back out. So it's the opposite of heat of fusion, and it starts to vibrate slowly again, and it forms that solid. Here, they're vibrating a little bit faster in the liquid, which allows them to spread out. Now we can also add a little bit more heat to this, and this heat is called the heat of vaporization. It's the amount of heat needed for vaporization or for that liquid to evaporate completely. So the heat of vaporization is applied and we turn it into a gas. Now look at the difference between our liquid over here, which is definite volume, indefinite shape. It flows around and takes the shape of the container. And the gases, they're all spread out. And they want to get as far away from each other as possible. It will take the shape of the container. As they bounce off of each other, they become random motions. It has an indefinite shape and an indefinite volume. And it will always take the entire shape of that container. So if we add a little bit more heat to that, we might become a plasma, but this is where we're going to stop today as far as the types of gases. Now we also have the opposite direction. Let's say we take the heat away from it. We're going to have deposition. Deposition is when we skip the liquid phase and we go right to the solid. That's when we take heat away rapidly. Now if we take heat away from the liquid, we have our freezing. Now one thing about water, if we're talking about water here, is water is one of the only types of compounds or molecules that expands when it cools off. Ice expands and has a volume greater than what water is. But still, we're going to be in that solid state where they're kind of sticking together. With condensation, now we're going from a gas cooling off and we get into our liquid. Right now, the blue here represents releasing heat. The red here represents our endothermic taking heat in and that energy that's there. So what you're going to do now is study this for a little bit. Make sure you get everything written down. Make sure you know the difference between deposition and sublimation. Sublimation is when we add so much heat to it that it goes right to a gas and it skips that liquid phase. Make sure you know the difference between melting and freezing. Make sure you know the difference in condensation and vaporization. These two words, heat of fusion and our heat of vaporization, are going to be two important vocabulary words for this chapter. Your mastery check will have you fill out one of these diagrams, or you're going to have to get a sentence and fill in the blanks with each one of these phase changes or each one of these types of our matter. All right, good luck and see me when you're done.